Welcome CSC 103 class. This is exercise 11, and it's called variable loops, and it's still drawing. We're still going to be working on drawing squares a little bit, but we're going to be working on being more efficient in our programming with Python. That's the whole idea of working with this. Is we start off doing a lot of repetitive stuff and a lot of things that take a long time to change, and you're copying and pasting things, and we're going to learn to do things more efficient using some programming tools or parts of our language, things like loops and things like that could make things more efficient. So that's what we're going to try and do with this. We're not going to do anything a whole lot different than we already did, but we're going to make our code be a whole lot more efficient. Because just for example, that's why I have the previous example open, our exercise 10 that we did of turtle squares. If we want to decide that, well, I don't want to make a square that's 100, I want to make it that's 75, we would actually have to go and change this to 75, that to 75. Every place where it's 100, we'd have to go and change it to 75. And then we'd have to change our starting point, because remember, our starting point was like half over of what the length was, and we'd have to refigure out all this math. We'd have to change these down here. It'd be a lot of work, and it just wouldn't be efficient. It'd be very prone to mistakes. So the idea, it'd be nice if we had something up here that just says, hey, okay, our length is 100, and then if we wanted to change that, we could say length is 75, and it would update all of these. And actually we do. It's called variables. And we're going to write some variables in the beginning, and then instead of using absolute numbers, we're going to use variables because they will change. And then we only have one place to change them. It's kind of like in PowerPoint when you use your slide master, and you can make changes in the slide master and it can update every single slide. It makes everything a lot more efficient. Changing your fonts, your bullets, your indents, your colors, anything you want to do on a slide master will update all your slides. And it's the same kind of principle here, that we want to be more efficient with our programming. It means less code, it means less chance for errors, and it means it'll be easier to update things. And because you won't have to go like look through and find all these things and do math. It'll be quicker too. So that's what we want, quicker and more efficient. Now here's an example of a finished one. The code's a little smaller here, but this is the example. Let me just run through it and what we're going to do. And you can see it's not much different than we did last time. There's a green square, there's a purple square, and we just didn't change these back to black. We could leave them their original colors, and you could change colors if you want. There's no problem doing that. So it's really the same thing, except look at a lot less code we're using for doing these, and we don't have all those repetitive things. And the nice thing about that is we're going to be able to go into here and say, okay, if we wanted to make this 75 instead of 100, we could go to one place here and type in 75 and run it, and now it'll run two squares that are 75 pixels, and everything's still centered on our X. Remember, 0, 0 in the center, so everything's still centered horizontally. Even if I change it to 50, anything I want, I could put any number in now. Eventually they may overlap if I get too small, because the turtles are a certain size. But I can make 50 pixel squares here with turtles, and notice they still go the same distance apart, and all we did was just do a little math of taking the length and dividing it in half, and just making it a negative number so it moves over. All that stuff that we kind of did as we were working on it, we could do ahead of time and figure that out. And that's kind of what programming is about, so that we can be more efficient and not have to pour through this code. I mean, this isn't a lot of code, but I mean, just think if this was hundreds and hundreds of lines of code and you had to go through and change every little number here and there. That's why making variables is very important. So we're going to do the same thing we did before. We're going to instantiate a new turtle named Timmy this time instead of Tommy and Tyler. We're going to make Timmy, and we could start him green, or you could use another color. And then we're going to start at some variables, and we're going to use some variables so that they can change. Now, in addition, we're also going to do something in here. You see this thing? This is a for loop. Notice that it's indented, because that means these two things are part of this for, I, and range thing. When we do that, that'll actually repeat all those forward, left, forward, left, forward, left that we had 8 times. So then we don't have to have this stuff repeated 8 times like that. We'll do it one time, and we're going to use a for loop to just tell it to repeat, and then that way we could kind of crunch things together. And we're still going to copy and paste and make a second turtle for now, but then we could still use our variables to update things, and we might just have to make 2 changes on our new turtle. So that's all we're going to do. So it's a lot like turtle squares, except it's using variable loops. So we're going to get started on that, and I'm going to go back here on my original one, and I'm just going to make a new trinket. So that's what I'll ask you to do, is just go to new trinket and just Python, not Python 3, and just call it 11, and we'll just call it variables loops. There we go. There's variable loops, and that's exercise 11, so now that's saved, even though I don't have anything here. And you could look at your previous one, but we'll try to go through and type it from the beginning. Here are the instructions. Here it's just in Word format, so I'll go through here because I may have to make some changes to it. But it's going to be called 11 variable loops unless that exercise name changes. If you're in a different semester, that number may change. And we're going to still instantiate our turtle named Timmy, and we're still going to give it a turtle shape and a turtle color. And then what we're going to do is we're going to create some variables. So that'll take us 1 through 6 is really just getting started, and that's kind of what we're doing here. So I'm going to get back and click in this window so it knows I'm working in here. So I'll do import turtle. And I always put like an extra space in there. And then we're going to make a new turtle named Timmy. So I'm still going to put a space in between here, and then we'll instantiate our new turtle. And we're going to call this one Timmy. And I'll say Timmy equals. That means you're making, this is the variable name or the instance name of the turtle named Timmy. And he's going to be equal to, from the turtle module and the turtle class, he's a turtle of the turtle class. So that's Timmy that's being created there. And I'll make my code a little bit bigger just for you so it's easier to see. And there's going to be Timmy, and then we'll also create his colors there. So then now that we have Timmy, we can start everything off with like Timmy dot. So we'll do Timmy dot color. We'll make sure he's green, put that in quotes, and then we'll make him his shape. Doesn't matter if you make his shape or color different. We'll do the shape, and then we'll do the parentheses, and if you put your quotes first, then you could type this in here, and we'll give him a turtle shape as well. So that'll create Timmy. If you run it, there's Timmy. So he's going to draw a square, and we're going to do it like last time. And we could start it like that. If you remember how we did it last time, we basically did a Timmy dot forward, and then I think we made him 100. That was a distance. We had to put a distance in there. And then we also did something like Timmy dot left, and then he turned 90 degrees. Now we did that. Now this is kind of how that gets started, and that kind of starts there. And then remember, we repeated that and we did that. Now what we're going to do differently this time, and if you go back to your instructions, you could take a look at this. We're going to start making some variables here. Now I even kind of got ahead of myself a little bit, but that's okay. We're going to go here and we're going to create some variables, and we're going to create a variable for length, and we're just going to do that first. That's the only variable we're going to create. So I'm going to go back here, and I'm going to do it. I guess I could do it. I'll do it after here. Let's see when I did it in my sample, just so I'm consistent. It looks like I created my variables after I instantiated Timmy, and that's okay, so we'll do that. So after I created Timmy, I'll create some variables here, and I'll even put a # variable so I know they're variables. And I'm going to do 1, and I'm going to call it length. So you just give it a name. Now in some languages you have to say var length equals something. You kind of define a variable and you give it a value. In this one, you just have to give it a name, and we'll give it a value of 100. Now you might say, well, we already have 100 there. Well, that's true. If now we're saying length equals 100, and we say forward, now we could actually replace this and use length. And now whenever we use length, length will be kind of linked to this. So then if we change the 100, it'll always be linked to that. So we're going to now use length because that's a variable that represents 100. So the same thing should happen. If I hit run, same thing should happen. So now it's using length, which represents 100. So that's what variables do. They represent numbers, they could represent colors, they could represent words, they could represent other variables, they could represent lists, all kinds of things. Variables are very powerful, and you have one place to go and kind of change them. And you can redefine variables. You can say, okay, now length is going to equal 100 plus something. So you could always keep changing them too. That's why they're variables. So this is one thing that's going to help us is by using this variable, and we're going to create other variables. And I'll go back to my instructions and see if there's any others to create right now. And for number 7, that's all we're doing is we're creating that one, and that's all we're going to do. And then we move on to page 2, and then we're going to use something called a for loop. And this is going to repeat creating the sides of the square. Instead of just copying and pasting and having 8 lines of code, we're just going to have the 2 lines of code, but we're going to use this thing called for I in range. That's a for loop, and what it's going to do, it's going to iterate 4 times by using this code. So I'm going to go back here, and I'm going to do it before I start this, and I'm going to say for I in range, and then in parentheses we got to put a number, and we're going to do it 4 times. And now the most important thing there's 2 important things. One is you have to put a colon, and I'll hit enter. And then you can see even when I hit enter, it indented this. And I also want to indent this. I could just hit the tab key. So it's very important that this is indented. So that means these are being kind of looped 4 times. These are being run 4 times. So it's going to iterate in this range 4 times. It's going to run these lines of code. So it's going to run these lines of code 4 times, these 2 lines, which will do the 8 like we used to. So we're not going to have to do that. We're not going to have to copy and paste these 3 more times. And if we try this out, let's just see what happens. It makes a square. Now, what it doesn't do yet, it doesn't center it. It also doesn't fill it. Now, the filling it is not a part of creating the square with the 4 sides. This is the 4 sides, so that's what made the 4 sides. It repeated that these 2 lines, which basically made 1 line 1 time, and then it ran through it and it did it 4 times total. So when we want to begin fill, we actually want to do that here. We actually want to do timmy.beginFill underscore fill. No arguments for fill, but notice Timmy begin fill is going to be before the for loop. So that's not going to, we're not going to be filling it 4 times. We're only going to be filling it once. So that'll start here. We're going to say begin fill, then it's going to draw the 4 sides, and then we're going to be done with this loop. We're going to come out of it and move back. So make sure you move your cursor back. So everything we're doing from now on is not going to be part of that loop. This is the only part of the loop, is just doing that. And now you might say, well, why didn't we make a variable for rotating? Well, we're only rotating 90 degrees, so that's not changing, so that doesn't help us here. Although if we did, eventually when we make polygons that actually rotate at different angles, when we make stop sign shapes and different things like that, this angle will change, and we will have a variable for that, but for right now we'll leave that at 90. And now we're gonna, I guess we're gonna end fill. So we can just do a timmy.endfill. And again, this should not be part of that, so if it goes there, just make sure you backspace, and this will be an end fill. It won't be begin fill, it'll be end fill, and that will create kind of the green, our green thing there. Okay, so, and then we're also going to have him jump to the middle of there. Now before we do that, now so we're almost halfway there, and I should probably save this. I'll hit my save button up here. Before we do that, let reset my size here. Now before we do that, I'll take a look at my instructions. Nothing wrong with looking at your instructions. So here we did our for loop, and that worked out okay. And we used length. We made sure those were indented. We saved it and we ran it. We did our begin fill and end fill. And we also have our begin. Do I mention the, yeah, the begin fill should be, I don't know if I mentioned that here. I'll make sure I fix the notes, because the begin fill should be before here. I don't know if I mentioned this here, but the begin fill should be before there. So we're going to need the, here it shows it in the notes, so I'll update those notes. So anyway, we're going to make some more variables. We already have length, but now we're going to make one for start x and start y. Since we had to do all that math to kind of make it go halfway over and down and all that stuff, so we're going to make variables so we don't have to kind of do the math within the parentheses, although in some cases we were. So we're going to make variables for start x, start y, and end x, end y. Because if you remember, you know, where the turtle starts, I'll run it here, you know, this is the start x, start y, and then where he ends, this is the end x, end y. So we're going to make a start x, start y, and end x, end y. So we're going to make a couple more variables. So we're just going to call, and you could call them whatever you want, just they can't start with numbers. There's all kinds of rules for these, but we'll call them start x equals, and I'll just put 0 for now because I'm not sure what I'm going to change it to. And I'll do start y, and I'll make that 0 because that's where it starts by default. And then I'll do end x equals, and I'll just do 0 for now, and then I'll do end y, and I'll say equals 0. So let's think about where we're starting. So we're starting at 0, 0. Now for this one, we're going to be starting, if we always want it to be centered, we always want to kind of take the length and be half of it and be over to the left. So if it's 100, we would take 100 minus divided by 2, which would be 50, and it would be negative 50. You'd move over like that. So, or if it was 50, you'd be 50 divided by 2 is 25. You'd be minus 25. So if you know what that is mathematically, you'd always be moving it over to the left half of the length. So it would always be negative half of the length. So you could say start x could really be negative length divided by 2. And that way it should move it over. and that would be start, and that's where the start x would be. Now we're starting at its default right now. We didn't put any start in there, so we're gonna have to put a go to start it, and it's y. We're just starting the start y at 0 as well. We're not putting anything special in there, I think, to start. Now the end x is always going to be equal to 0 because it's always going to be centered. We always want the turtle in the center. So this will put it in the center by taking that divided by 2 and doing the negative. The start y, we're keeping it here right now in the center for now. The end x will always be 0 because we always want the turtle centered. And even if you put a note here, you could even put turtle always centered. That's fine. You could do that. And the end y, if you remember, it was basically always minus 25. So it could always, and so the way you could do that is you could do whatever the start y is, and the reason I'm doing this is because if you make another one, let's put start y, and we're going to put minus 25. So whatever the start y is, it'll be minus 25. That way, if we make a second one, we only have to change the start y. Now you could have just put minus 25 here, but that way you're kind of doing it based on the other variable. You're saying end y is start y minus 25. So if you change start y, it'll always be minus. If you change start y to down a little bit, it'll be minus 25 from that. So the turtle will always be 25 away. So it's nice taking a variable based on another variable rather than using an absolute number. And let's see what happens here by using these variables. Now, we didn't do anything yet, so nothing's really going to happen. It's not going to really update yet because we didn't really give it a goto. So remember, we have to do that goto stuff. So let's do timmy.goto, and we have to put xy's in here. And instead of putting xy's, we're just going to tell them to go to start x and start y. The starting point is going to be start x and start y, whatever value we're using for that. So we're going to say Timmy go to start x, start y, and that's where he's going to go to start, and it should use this stuff to figure it out. And then let's see, we're going to begin fill. We might have to do a pen down. I'm not sure if it moves over, if we're going to have to do a pen down or not. I'll skip that for now. And then at the end, remember, we're also going to do this. So I'll copy this, because you remember at the end we did this whole thing with, and I'll paste it right here. We had to do a Timmy pen up. I shouldn't be messing around with the pen ups right now, but we had to do a pen up, and then he had to go to this little point and then turn. So basically where he's going to go at the end, he's going to go to end x, which will be 0, and he's going to go to end y, which will be start y minus 25. So end x, end y. So let's see what happens here. I mean, you could certainly just save it, and I'm going to run it, and it's in the center. You can see it's centered now. Now he didn't turn, and I forgot to do that, so I'll go in my area here, and the one thing I didn't do is after we do pen up and after he goes to there, I didn't have him turn, so we'll just have Timmy.left and then make sure he goes 90 degrees, and I'll run it again. And there, that's exactly what we want. So that's the first part of it. So all we're going to do is copy and paste that and just adjust one thing. And actually, I don't have to make a second video. We should be able to do this real quick. If we want to make another turtle named somebody else, named Bobby or something, we should be able to just make a Bobby. We don't need to make new variables, and we should only have to change the start. We should only have to change Bobby's start. So if we're going to make another turtle here, let's make another turtle. And let me check my instructions before I get ahead of myself here. Let's just check the code here. And we did that, and there's go to. So everything looks like the Timmy stuff we did. And that all looks fine. And now what we're going to do, this creating the second square, we're going to create one named Bobby. So we're going to create a new Bobby. And maybe we could copy and paste this first and then copy and paste the other code. That might be easier than copying everything and deleting stuff. So I'm going to go here and I'm just going to create another turtle, and I'll copy the Timmy stuff and go below here, and I'll make sure I'm in here and I scroll in here. So after this very last statement here, I'll have a Timmy here and I'll name it Bobby, and I'll double click here, and I'm afraid hopefully this won't change everything. No, it won't change. So I'll change that to Bobby. So I got a new turtle named Bobby. He's green. I'm going to make him purple. So there's a new turtle named, and if I run this, we might just see a turtle at the end. And there he is. There's the turtle we just created. Now what we're going to make him go to a certain place. So I'm going to go up here and copy all my Timmy code. We don't have to copy the variables. Just going to copy the Timmy code here. And I'm going to go here and I'm going to paste this. And all this Timmy stuff, I'm going to call this Bobby. And then I'm going to highlight on that and then control click this, this, this. If it's not too many, you could just kind of do it like that. And I'll change all those to Bobby. And so I have all this Bobby stuff here. Now, Bobby's going to go to start X and start Y. Now, the only thing that's going to change with Bobby is going to be his start Y. His start X is going to be the same. His start Y is going to be different. So, I mean, you could really create another variable for that, or you could just start Y. I think what we did last time is we just did a minus 150. And you could just do something like that. Now, you could do a variable and make another variable called, like, you know, Bobby start Y or something, or do 150. But this should be the only change we should have to make, because once he starts, the other one is based on that. So let's just see what happens here with Bobby. Since we have the new Bobby, we have just the start Y is the only thing changing out of all our code. And let's run it. And there's Tommy, or whoever that was. And he goes back to the beginning. So he went back to the beginning. So we have to find out why he went back to the end X and end Y. Oh, because it doesn't understand the start Y. Because it's still starting at the same start Y, so we have to change two of them. So we have to change the end Y as well. Even though it does have the minus 25 built in, we still have to do the minus 50. So there could be a way we could do that, but that's two changes. Not that bad, other than changing names if we do. And also we have to do, because he's jumping to a new position, we have to do a pen up. So before he goes here, we're gonna have to do a pen up and then a pen down, so then he can. So before he goes to here, we'll do Bobby.penUp. And then after he goes there and starts drawing the square, we'll do Bobby.penDown. And then that should work okay. So there's Timmy, and now there's Bobby. And what we should be able to do here, now that we have this now we have these kind of the same distance apart, so even if we make them smaller, they'll be the same distance apart. I don't know. I don't remember. Let me just look here. I guess I end Y. Let's see what I did here. Minus length. I might have tried to figure out something to get it a little closer. And we could figure out something like that if we want to, or we could do that in class. For now, because that's going to be an absolute value of that 150, and if they get smaller, they're going to be kind of further apart, which may be an issue. So we may have to figure out something that works a little better with that. But let's just see if we change this length to 50. See what happens. And there's the smallest one. And you can see they're a lot further apart now, so you'd almost want to figure out a value for that 150 that's a little more in proportion. And we could do that if we want. And by looking at this one, it looks like what I did here, and let me see if it's in the instructions. I don't have to like go explain myself. And yeah, I do have it in the instructions. Okay. So what we did here is to make it more proportion, we used the length. So that way it's only going to be 50 less than whatever the length is. So it'll be more in proportion. So instead of just doing 150, because we did that because the original squares were 100. So I should go back and fix that. So instead of doing minus 150, here what we'll do is we'll do minus length minus 50. So whatever the start Y is, so if the start Y is 0, we minus the length, so it would be minus 50, and then it kind of adds more to that. So that's all. So if we do end Y and we do minus length minus 150, or minus just 50. So the 100 was kind of taking into account the size of the square. Now because the size of the square is variable, then why not just use the variable? We'll use length, and then we're just going to kind of add, so they'll always be kind of 50 pixels apart, which at least they won't make them so far apart when they get real small. So that way, if we go back up here and we change the length back to maybe 150. Now this is probably going to go off our little screen here. Probably get cut off. Now there it goes down there. That's not too bad. It's still 50 pixels apart. And now if I go 75, it should still be 50 pixels from, based on where that is. So it's always keeping it 50 pixels apart, which is a little more, it's not completely in proportion, but it's actually kind of a nicer kind of way to do it. And by using variables, it always makes it a little more. Now this is a little more confusing because you're going start y minus length. You could probably set up a different variable if you wanted to make a little more sense, I guess. But this is one way, by kind of subtracting the length and then 50 instead of 150. That makes a little more sense because it's variable based on the length, and there's always better ways to do it. Just what we're doing here, copying and pasting code, is not efficient. Copying Bobby and changing all the names to Bobby is not the most efficient way. We're going to work on more efficient ways to do everything. That's why we're going to create functions and be doing more things like this. But we're starting to get a little more efficient. We're able to do this with a lot less code, and not only a lot less code, but we're able to update it a lot easier by just changing one number, which makes it a lot better. So that's exercise what was 11, and this is variable loops, and same thing. And I even have on this instruction, I have a little screenshot of what you should do when you basically copy the link. And copying a link basically is going here to share, going to link, and then copying this link, Control C. And then, since I'm not going to go into my LMS right now, you basically add a comment for your exercise, and you're going to paste it in here, and then make sure you make it open in a new window. Make sure you use the hyperlink so it's actually a link, and make sure you make it a new window so when your instructor clicks on it, it'll open in a new window. It won't take them out of their LMS. And then just save it, and that's all you have to do. So those instructions are on there as well, and that's all you should. I'll double check to make sure the instructions on here are okay, and everything should be okay for exercise 11, variables loops.